We'll move over to Katie for an introduction on what your work on groundwater.
Great. I work in the groundwater section of GSI. Groundwater is a important, naturally good quality, resilient water supply. By its nature, it's out of sight, out of mind, and it's often overlooked. I think when people think about groundwater, when they think about water resources, they think more about the surface ROs on the image on the slide. So rainfall falling on a catchment and running straight off into the river. But what also happens everywhere in the country is that rainfall seeps into the soils, through the subsoils, and down into the aquifers, which are rocks that hold water, and fill up the cracks and spaces in the rocks under our feet. So groundwater is it's important. It supplies drinking water supply, it supplies industry, it supplies agriculture, and also it supports our river flows, it supports our lakes. So you can see the arrows under the surface show the groundwater flow. So it's flowing through the network of cracks in the rocks and flowing into the rivers. So particularly in the summertime where there's not much rainfall, it's groundwater that's supporting the rivers and supporting the ecosystems in those rivers. In GSI, we look at two aspects of groundwater. So first of all, we look at groundwater quality, and groundwater has a naturally good protection. So the rainfall, unlike rivers, is flowing through the soils and subsoils, which can filter the groundwater and remove some of the particularly microbiological contamination. But of course, groundwater can get contaminated from surface activity, so by farming or septic tanks or industry. And so we do a lot of work at looking at groundwater protection, so understanding where there's vulnerable areas, where there's well-protected areas, and what measures we need to put in place to protect the groundwater. And the other aspect we look at is groundwater quantity. So trying to understand where we have really good resources of groundwater. And we all know the climate change is changing how rainfall is happening, and will change the groundwater, will change the resources, water resources. And so understanding how groundwater can play a part in allowing to mitigate the impact of climate change on our water resources.
First of all, we know climate change is here now. We don't have to argue about that anymore, and at least we've got over that. But people are still kind of looking at what does that mean for Ireland, And one of the things we've looked at in our series as well is and the science is saying that look, we're going to have more extreme weathers, and droughts are going to be a potential issue. These long periods of no rain, which people might be happy about in Ireland, but our water resources in Ireland are quite stretched at times, aren't they? We have times of the year, particularly in the eastern region, that they're turning the taps down, and they're saying, look, we got to tighten our belts here. So are we vulnerable? What are our potential resources here in Ireland? It rains a lot generally. Can we trap that more? Start there.
Yeah, so I think if you say to lots of Irish people that drought's a problem, or this is a issue, then the first reaction is, oh, but sure, it rains all the time. And on a global scale, that's true. We're in a really fortunate position. We do have a lot of rain. We're it's not very hot. We have a lot of water resources, but as you say, we know that climate change is changing that, and that the predictions are that more extreme weather, wetter winters, drier summers. And I think the 2018, 2020, those dry summers really brought that into focus for people. So for the 2020, that dry summer, almost 1 million people's water supply were in drought status. So it just brings into focus that it is something that we need to consider. It's not something that we can say, sure, it rains all the time, it doesn't matter.
Yeah. 1 million people's water supply. So if the drought had gone a month longer, because that could happen maybe in the future, a month longer, what would have happened then?
So then we would have been in real trouble, and more. So at the time they put in the hosepipe ban.
Yeah.
But and we were very, then we were lucky that there was rainfall. And so we had enough water, but it has the potential that
Yeah, I
could have
remember
continued.
it was looked really desperate, and then all of a sudden we got loads of rain.
Yeah,
It did crash, but if it had gone on longer,
yeah, and
we
in
would
the
have
future, the predictions are that
that will
those
happen.
could be those drier
Yeah.
summers are predicted. And so in that case, then we need to start putting in more extreme water rationing measures. And what we do in GSI is we in the groundwater section, we're looking at groundwater quantity. So groundwater is stored in rocks under the ground, and it moves more slowly than surface water. So if a surface water supply is impacted, then the groundwater sort of moves more slowly than that. So it's still rising when the surface water, when it's summertime and the rainfall is not replenishing the surface water. So there's a potential where you can use conjunctive use, so that you could, in the summertime, be using groundwater resources to complement the surface water resources when they get into trouble. And then when the surface waters recover, go back to the surface waters. So that's the sort of thing we're looking at, as well as identifying areas in the country where there's, good potential for, sustainable, resilient groundwater supplies for drinking water or for other big obstructions.
Just taking a step back for a little second, there's groundwater and surface water, and roughly how much do we rely on each?
Yeah, so groundwater is water that's in the ground, surface water is rivers, lakes.
That's the rainfall that comes down, gets trapped in, on the land and falls through rivers into lakes.
Yeah.
That's
so
surface water.
We quantify all of those as geologists, we call those surface waters, and then the groundwater is water that's
drilled down and you can pump it up.
Exactly, yeah.
And how much we rely on each roughly?
So for public water supply, it's something like 20% of our public water supply comes from groundwater. So
20%.
Yeah, so 80%.
From drilling down,
yeah.
And 80 from the surface.
From the surface water. But that changes in different counties. So for Laois, it's almost 100% groundwater. For
100% groundwater in Laois. Okay.
And
so do they not have many rivers and lakes, or is it just easier to get?
There's a good resource there from groundwater. And
they're just easier to drill down than actually pump from there.
So probably a combination of both. And Offaly and Roscommon, it's a very high, 60 or 70%.
Yeah.
And there's also an urban-rural split. So typically the rural communities use groundwater more. So either via private wells or by group water schemes.
Is that because it's piping it from the river is probably has to go across land and has to go through over roads and under roads and things like that. So
exactly,
it's hard to access, whereas you can always just go drill down if you have to.
So for a town, it makes sense to put in the infrastructure for a reservoir or for something. But if you have a distributed population,
now we're very spread out.
You're a farmer. Your easiest option is to drill a well, and that's so that the rural population rely on groundwater for drinking water and for livestock and farming.
What's healthier? I mean, there's contamination in both groundwater and surface water, and there's all kind of, this boil water notices coming up every now and then in different regions and things like that.
Yeah.
And, there's different treatment levels for each as well. And if you're in a town, you might have a treatment level system that's new and it works, or it's old but doesn't work very well.
Yeah.
But generally, if we didn't have any treatment, what would be the best water you'd be drinking? What would you trust more? You drink out of a lake, random lake in Ireland, or drill down and drink out of the ground?
Yeah, so groundwater is naturally good quality water. It has a natural protection. So the rainfall is falling on the ground surface and then it's filtered through the soils and the subsoils before it gets into the rocks. So particularly
because groundwater was once, for surface water, it's just taken a long time to trickle down into these aquifers.
Right? So it's rain that's fallen on a field, soaked in, hasn't been used by the crops, and then trickles down through the soils, through the subsoils, into that network of cracks in the rock. And so if you think about natural mineral water, spring water, those are groundwater sources. So they're and all of their marketing is based on the sort of purity of groundwater because it's got that natural filter. In Ireland, we use the Water Framework Directive to assess, the quality of our water resources. And for the groundwater bodies, 8% of the groundwater bodies are at less than good status. So 8% we'd like to have better quality in our groundwater.
In the groundwater, only 8% are not great.
Are not great. Whereas in the lakes and rivers, it's more like 50%. It's 47, 49%.
And that's mostly agricultural enough, isn't it?
It depends on the area.
Depends on the area,
Agricultural, forestry, industry, wastewater treatment. You know, there's a range of different pressures. So, you know, groundwater has that protection. And
so these pressures are on the surface water
everywhere.
And somehow when it seeps through the ground, you know, dirt in the soil, people, you know, just it's hard for people to understand that actually that filtration, it ends up deep down and ends up being very clean.
Yeah, so obviously it, you know, it depends on the contamination. Some of that contamination can get down through into the groundwater, and
so we really don't want to be contaminating the surface water.
Yes, so
even if we're only reliant on the groundwater, the surface water does matter.
Yes, and what happens on the land surface. So it's, you know, it's the rainfall that falls on the land surface, you know, away from the rivers, it's trickling down into the groundwater, and then that water comes up into the rivers. And the, I've lost my train of thought now. I can't remember what I was going to say. Sorry.
No, I just think it's fascinating that you know, when we drill down, usually it's pretty clean down there. You know, but that was surface water. You know, that is just somehow the dirt that you know. I know you wouldn't use that terminology, but you know, earth and things and stones just running past it has cleaned it somehow. You know, it's taken out the bacteria and things like that.
So we have the you know, like a natural filtration from the subsoils, and in some areas those exist and they're very effective, and in some areas they're, you know, they're not. The soils are thin, the subsoils are thin, and so then any contamination on the land surface from farming or whatever can get straight into the groundwaters. And we do a lot of work in looking at where groundwater is vulnerable and where it's well protected, and understanding that we need to manage the surface activities to protect the groundwater, both the surface water and the groundwater.
Sometimes, depending on the layers of rock and soil and other minerals or materials that are between the surface and the aquifer, sometimes that, you know, that material will filter very pristine water, and sometimes it'll just flood down there somehow, and it'll
depending on the setting. So in the west of Ireland, we have karst groundwater where the cracks are dissolved by the rainfall. So you get, you know, think Marble Arch caves, think, you know, large conduits. So and there typically the soils are very thin. And so any contamination on the land surface can immediately get into
tanks that are broken, or if there's you know, some of the wastewater treatment plants in Ireland aren't working very well, and they can overflow, especially when it's the flood events that can affect things too. So they'll flood straight down into the aquifers.
Yes, so they can do so, and at those points,
and a lot of people there are reliant on groundwater.
Yeah, so it's, you know, it's in those areas that it's important to think about how we can control those surface activities so that contamination doesn't get into the groundwater or get into the rivers. You know, so it's controlling where you can do the different activities and understanding where the vulnerabilities are. And then, you know, that's our sort of role. And then the next stage moves on.
So some areas we have to be very careful what we do, because this is going to be directly affecting the aquifer. And some areas we can kind of go, well,
it's well protected naturally.
It's well protected. You don't have to worry about the aquifer here. You know, we might worry about other things, but the aquifer is going to be okay. So I suppose that makes very interesting science, and what you're doing there. Just, you know, you need to map the country out, which you're probably doing.
Which we've done,
and you can kind of say, look, this is very sensitive. We have to be careful here, and here we have to be. We don't have to be so careful with the aquifers. So we've done a lot of mapping on the groundwater vulnerability, and GSI has got a long record in that groundwater protection. So understanding exactly where the catchment to a particular borehole is, understanding which areas in that have natural protection, and which areas need to be we need to be thinking about those land activities, and you know, putting in recommendations of, you know, it could be just putting in a buffer zone so that land spreading doesn't go right up to a karst feature, or, you know, there's a lot of, you know, other things we can do
activities that can
based on
be,
this mapping.
yeah,
We can-
exactly.
yeah, okay, very good, very good. The other part then that's related to climate change is what, you know, if things get really bad, you know, droughts and things like that, and also the amount of water we're using for industry and agriculture, everything else is going up, you know, in some cases. You know, there's data centers being built, and, you know, do we have shortages coming? And we already have shortages, but, you know, where does that end up, you know? Do we have enough in the ground that we can just keep drilling, or how does it work?
Yeah, so it's so the you know, the predictions are that water resources are changing, and at the minute we're in a very comfortable or reasonably comfortable position, certainly comparing to internationally. But, you know, we need to have a better understanding of our resources and understand exactly, you know, where there are good resources, both surface water and groundwater. We're obviously concentrating on the groundwater. So where there are good groundwater resources, and we're looking at a project, we're working in the east of the country at the minute, because that's where the large populations are, that's where the pressures on the water systems are. And we're looking at where there are good resources. So where the aquifers are good, where there's lots of interconnected fractures, and we have that mapped, and where there's good recharge. So where the rainfall can easily get down into the aquifer.
There are places we can be drilling more and extracting more water.
Yes.
And there's probably a rate of extraction that's okay. And you guys have to work out how much can we extract here, and
from the different aquifer types.
Different aquifer
Yeah.
types.
So we have, you know, three. The aquifer types are broadly split into three. So poorly productive, locally productive, and then regionally productive. And so where, you know, where can we get good groundwater resources? And then the other side of the project is looking at what are the constraints to that. So if we drill here, are we going to, you know, affect important ecological site? Or if we drill here, is there going to be a chemistry issue? Or, you know, are there, you know, thinking about impacts of climate change? And, you know, is this area already quite close to a threshold? Then, you know, we know that in 20, 50 years time, there's going to be 10, 15, 20% less water in the summertime. So, you know, factoring those things in to make sure we're recommending areas that have a long-term, resilient, sustainable groundwater supply.